There we go. PyTorch. PyTorch. So, this is a Python front end to the Torch machine learning library, very similar to TensorFlow and what it can accomplish, or what its use case is, I should say. I dabbled in it, I looked at it probably, I don't know, in the earlier iteration of the channel, I guess 3 years ago or so. But I've heard a lot of good things since then. I think then I wasn't able to get it to do what I wanted, but I'm hopeful that now I can. One quick comment, I don't have my side laptop today, so I'll not be in the chat at all. Please send me an email or leave a comment on the YouTube video if that is the situation. You need to get a hold of me. Don't worry about it. Anyway, we want to try to install PyTorch tonight, and then, actually run it and see what we can do. Funnily enough, I have my code from when we tried to do this before. Let me get rid of that, don't need that. Apparently it was just called Torch, and I tried to do some Keras stuff and load it and run it, and I don't think it worked very well. It worked better than some of the other libraries. Anyway, PyTorch comes from, I think, Facebook originally. Well, not originally, but I believe it's tightly coupled with Facebook. They got blog, ecosystem, all this other stuff, get started, tutorials. Let's try get started as well. Get started. I've not even installed it, so this is starting from nothing. Ooh, you can just pick up a bunch of things. Package, back for pip. That's my thing. What is my CUDA? Oh boy. CUDA version. Ubuntu CUDA version. I think you can look at it with like NVCC. Yeah, clearly I've looked at this page before. NVCC -- version. NVCC -- mine's probably like 8. Not found, of course. Of course. Or you can query it, or just cat this thing. You can just check this. There we go. 10. Oh, cool. I knew it was CUDA 10. Well, that's super neat. 10.0. Is that going to be okay? 10.1 is what you want. We'll try 10.1. It's like 9.2, 10.1. Oh. Run this command. Pip install torch vision. Interesting. Note that libtorch is only available for C++. That's fine. Libtorch. Source. Oh, cool. Installing on Linux. PyTorch's CUDA support. Yeah. So I don't want to screw around with this too much. If CUDA's not going to work with it out of the box, I'm not going to fight with that on stream. Sudo app. No, I already have Python. I'm not using Anaconda. I'm using pip. Oh, let's see if pip is working today, though. Pip has been badly behaved for me recently. Also, I apologize. I'm also eating on stream. I've been out of pasta for a while, but the local Italian bakery came to the rescue. They are well stocked. So I highly recommend supporting your local businesses like that, especially during these times. Oh, Pip's gonna be dumb. I can tell her already. Does not take this long. Come on, Pip. Anyway, let's take a look at the tutorial. 60-minute blitz. Well, that's exactly how much time we have, so let's see what we can do. A 60-minute blitz. Ooh, I do like visiting. Wait, training with TensorBoard together. This is weird. TensorBoard, primarily I thought that was a Google product. Well, that's cool. Yeah, 60-minute blitz. Oh, really? Make sure you have Torch and Torch Vision packages installed. I'm working on it. Oh man, that's taking its sweet time. There we go. It's not installing 10 million things, it's just being weird about the one thing it is installing. But I'm also broadcasting at the same time, so the internet, 10 megs a second. Not the best, not the worst. I pay for significant internet. I think right now I'm getting my money's worth. Oh no. The important thing is this progress bar, so I can see something happening. Ooh. Makes a big difference. Alright, so that might actually work. If it doesn't, I'll be real annoyed. How do you install it without CUDA? So this is a downside. In TensorFlow, you don't have to install some wackadoodle version anymore. You just always install the same version. If you don't have CUDA or GPU or whatever, it just uses the CPU version, or you can tell it to use that. It looks like here it's very specific. That's one downside. Do the preview nightly. Oh man, crazy. What is PyTorch? No, I'm pretty sure I know what PyTorch is, but let's click to the next one. Why is your tutorial as though you're using Python 2? What kind of foolishness is this? I mean, this works fine in Py 3, but it's dumb. Look, Python 2 is dead. It's dead. It's never coming back. So don't. Just don't. Just stop. It's like when TensorFlow just came out as Python 2 only. I got mad, and eventually they released Python 3. Hey, what do you know? But Python 3, it's not the way of the future. It's the way of right now. Yeah, here we go. Go down, install, blah, 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 blah. Version die. So if I sudo do this, let's see. Can't write, that's right. Pip is being super dumb. What if I did this? It'd be the same problem? Oh god, is it gonna have to collect the whole damn thing again? Oh dear lord. What a mess. Yeah, I don't know why my pip is messed up. Pip cannot import main. I should try to fix this, and maybe that's going to be the whole episode. Why pip doesn't work. Yeah. Or is it pip? There's a problem pip 3. So consider upgrading my pip install. You know what? Let's try that. Sure. God, this is slow. That's horrendous. Pip should never take this long. Also permission denied. So we'll sudo all this. Yeah, so it's like it doesn't even want to do that. Pip 3? No, same problem. Same issue, same issue, same issue. People have been having this problem for a couple of years. Pip 10 in the user site, but doesn't uninstall the system copy of pip. User runs the system wrapper from whatever, which is always supplied. Just pip wrapper installed when you install pip 10 in --user. Ah, I see what the problem is. I have a user installed pip, which was wrong. And that's what it's calling here. Or this isn't the not user installed. Which pip? Really? Okay. Actually, let me have a look-see at this file. Is this anything interesting? Yeah, not surprising. From pip dot whatever, whatever, whatever. So that seems to be what we want. Install ---- upgrade pip. Let me see what this. Maybe that'll do the right thing. Like, I need to upgrade the system-wide installation of pip before I can do any of this nonsense. So, this is not Torch's fault. This is my fault. Because I don't run Anaconda or anything else. Directory, blah, 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 don't care. Oh, she'll help me. Are you going to install wacky things in my user? I might be just about to do terrible things to my user directory. Self-check, I guess? There you go. No, it all seems fine. Hunky-dory. Slightly different. Setting issues. We're overwriting system pip. Using an older pip wrapper against a newer version of pip. That's not a supported scenario. Still the same problem. Yeah, well, you didn't actually try this old. #d pip. What does this do? Collecting pip. Jesus. I'm such a record name pip. I don't know what that did. This guy's being cute. Yeah, uninstall, reinstall pip is probably the right move. That is probably the correct answer. Successfully installed pip. Which pip? Okay, well that's a plus. Pip. Here we go. See if this works. If not, we'll do this reinstall thing. Whereas parent directory is not owned by blah 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 blah. Don't care. You may want to use sudo's .h flag. Well, it's a little late for that, now isn't it? I think they should have fixed before the stream. Yeah, this is just god-awful slow. That's horrendous. What's the stream rate? Doing like a megasecond or something. Not great. Not great. But again, we're going to be looking at Torch. Okay, let me just look at the tutorial so I know what I'm looking at here. What is PyTorch? It's a Python library. Use the torch. Oh my gosh. Machine learning based. So you can construct tensors, like, which are just multi-dimensional matrices. Does not contain definite knowledge. But I believe one of the nice things about Torch is you can get eager execution, like this. Like when you go to print, you just get to see what's in there right now. Whereas in TensorFlow, you sort of have that in 2.0, but it's kind of a pain, doesn't work really great, and it's not made to do that from the ground up. Whereas Torch kind of is. It's some random numbers between 0 and 1. We're going to print, we're going to get those. And you can just see them. That's so convenient. Like, that puts you closer to your data. Like, that's the most important thing. Like, you can change the data type here, usual kinds of things. A long is essentially an integer. Depending on what system you're on, is 4 bytes or 8 bytes, probably 4. Shows a tensor directly from data. Super cool. Super cool. Notice this is floating point by default. That's pretty typical. You get double precision, which I believe is usually 8 bytes. But again, that is system dependent. Do not depend on that being a particular size. But usually it's 8. Float, that's probably going to be float 32, typically. Result has the same size. What do you mean size in this context? New star, oh, new ones? Whoa, what is this? Zeros is a thing. Why do you say new ones? Just say ones. That's the NumPy standard. Just do that. Ooh, I like this. Random numbers like. So make this the same shape. Give me a bunch of random numbers that are in the same shape as this. Super handy. The number of times I've had some weird problem, it's been because my shape of my data is super weird, but testing that isn't obvious. So make something that's the same shape but filled with random numbers. Do you still have the problem? Congratulations, it's not your data, it's what you're doing to it. Do you not have the problem anymore? It's probably your data. Heebity-jeebity. Okay, it's going. It's doing something. We installed Torch. Quiet rounding satisfied. NumPy, good. 6, good. Cool. What did it install up here? That doesn't look like Torch. Torch Vision. Oh, it is. Okay. Okay, well, maybe we have Torch now. I am gonna... Yeah. That's what we're gonna do. We're gonna make a new file of, not Torch 2, but, DanDoesData Torch, what is it, 1.4, I guess? 1.4.python. Import Torch. Alright, let's see what happens here. Torch, Torch, Torch. Yeah, big money, big money. Yeah, cool, look at that. Torch dot, here's the question. Like, what can I do? Is it like an is GPU? No. Is it like a GPU? Is it like a device? Oh, what's this? None. Right? No, it's a type, I see. That's silly. I want to know, am I on, check if I'm on the GPU. That's really what's important to me. You're not showing me that right here. Maybe it is and I'm missing it, that's okay. Because I will just say PyTorch check check GPU. Am I using the GPU? Boom, number one question right here. Torch.cuda.version, there you go. Okay, so that's the answer. 0, that's probably bad. I feel like that's bad. This is going to work. Torch.CUDA. Oh, okay. I don't know what current... Oh, that's current device. Right. So really we want is available. So that's the device name. Which GPU? True. Cool. What does it know about my GPU? Everyone needs to learn what kind of GPU I'm running right now. GeForce GTX 1060, 6 gigabytes. I got it because it was 6 gigabytes. That's the number one thing I was looking for. 8 gigabytes was too expensive. Okay, so we're on the GPU. That is good. There should be one device. Yep, I have one GPU. I tried to keep my original GPU when I upgraded last year, but I could not have both of them in at once, I found out. Okay, we're on the GPU. Now we can just plow ahead with this tutorial stuff. So let's make some stuff. Torch. Oh gosh, I do not have the patience to keep writing torch though. We're gonna write torch as TR. I like 2-letter shorthand for my Python libraries. That's how NumPy works. People use TensorFlow that way. I mean, PyTorch could be PT, but yeah, it's just torch. Torch dot was empty. You give it a shape, right? Yeah, 5.3. Wait, you give it a shape of not as a tuple, but as a... This is insane. X. What? What? There's stuff in there. Is that just whatever happens to be in there? What kind of insanity is this? What if I print it? What? What is this madness? Uninitialized. Does not contain definite values or is known. Understood just created whatever values in the algorithm have new times. Okay, they just happen to get zeros. They happen to get... That's probably what you're most likely to happen. These are not zeros, obviously. This is whatever happens to be in that memory location. You're never guaranteed to have it 0. If you want it to be 0, you should set it to 0. Important things to note. What I find weird is that... Oh, not TF. Jeez, oh man. That's going to take a little bit of time. Size is just $. Why not just pass in a tuple, man? A sequence of integers defining the shape output tensor can be variable number of arguments or a collection like a list or tuple. Okay, you can do either way. Alright, I suppose if this is the only thing you're doing, then that's fine. Because you can also do... I think this is more Pythonic, or even this, right? I'm passing in argument, this is the size of the object I want. And it's, okay, this one's almost all zeros, except for a little bit over here. It's probably like a single 1 in the end. What is, can I get like the D-type? Yeah, okay. Starting float 32s, cool. Okay, that's super neat. And I love that yet again, I can just look at this, I don't have to do any TF function, or other nonsense, I just get it. So getting your data right away, major plus to Torch. Okay. You make some random numbers. Torch.rand. How does rand work? Same way. What's out? Oh, you can tell the output tensor. Okay. I like 2x2, frankly. And I'm going to continue to use like a list or something else. Random numbers between 0 and 1. Right. This is a standard kind of thing you do. If I did something like this, I get a new value. It's like a y.numpy. Oh, nice. Get the actual array. Note there's slightly different displays, but I'm pretty sure they contain the same numbers. Here's a question. Can I do this? Oh, it doesn't do element by element wise comparison. Interesting. And yet if I said x, that's not going to work. Y equals, we'll make y2. Make some more random numbers. y2, y minus y2. Obviously, you can do things like that. Are they equal? I can ask. No. I can do things like that. I want to pull out all the elements of y where y is bigger than y2. Can I do that? You can! Nice. So it's a very NumPy-like construction where you pass in some kind of mask and you get out those elements. Can I pull out from y very specific elements, like 0, 1, hang on, the element in position 0, 0, and the element in position, I don't know, 1, 1. Is this a thing I can do? I swear I can do this in NumPy. That's not right. What is Y? That is the position in 0, 1. Interesting. Oh, it's 0, 1, 0, 1. Okay, hang on. In 0, 0, 0, and 1, 1. Yes, and that's 0, 0, and 1, 1. Okay, that's kind of neat. So you can make new tensors, you can do things like this. I love that you can print them. Print y, or you can print y.numpy. Super good. I'm a fan. Let me say y2 equals tr.rand 2. Or actually, there's a... No, I don't want zeros. I don't want arbitrary tensor. Rand n like, that's what I want. Let's use that. Rand n like. We'll put in y. Yeah. So it'll make random numbers in the same shape as this guy. Oh, wait. This is using a different distribution. Rand n like. What is this? Not YR. Trend center, same shape is filled with... Oh, use normal distribution. Okay. Rand n... Is there no other... Is there a rand alike? Oh, there is. Okay, cool. And this is uniform distribution. So pretty much from those you can build up more or less what you need to build. Okay, so I'd actually just try to do that. Y2, and then I would like my y of y greater than y2. Let's print that. Cool. Nice. Now there's only one entry, slightly different values. Okay, that is super neat. So that's a nice little feature. I think TensorFlow has this in a lot of ways as well, but that's just a nice little thing that exists. New ones. Is there not just a... Oh! I misunderstood this. This is saying, take the original object x, give me a new... Takes in sizes. New ones of this shape. What? Reuse properties of the input tensor unless new values are provided. What is this? This is different. Oh, it doesn't even exist. It's only a property of... Oh, an existing tensor. You get a new tensor of the size filled with ones, unless you give it a new size, or a new d-type, or a new whatever. That's cool. So I can say z equals, x dot new ones. I can just do this, just straight up. I can't do that? Then what the hell's the point? Returns a sensor of size, attribute size. Has the same class as there's. I bet there's a tr dot ones. Yeah, okay, that's probably what I want. There's a ones like, isn't there? Yeah, I suspect that's gonna be more useful. Build a scalar ones value same size is equivalent to all this other stuff. Like that's really more what you want. This is trying to be object oriented, but it's just kind of annoying. Like, I don't want this. Hang on. I just want this x. Or ones like. That's what you want. That's the good, nice, straightforward way to do whatever it is that you want to do. So yes, I strongly prefer tr.ones like. And again, if you have some comment, if I'm totally wrong, I'm not looking at the chat right now. I don't have the chat open. I can't help you. I'm very sorry. This is not as interactive as it might sometimes be. Anyway, cool. You can make random numbers like that. Cool. You can get the size of something. Is in fact a tuple, so it supports all tuple operations. I have a question though. Look at this thing. It can call for capital size? Oh no, okay, you call torch.size. Is there a size? Shape? Size. And this is the same as torch.size of z, right? Takes an iterable of int. What? Oh, okay. It's a... What is tr.size then? Is literally a tuple? It is not literally a tuple. No. It is something that inherits from tuple. Let's interrogate it further. I don't get to see anything. Oh, you bastard. I always hate it. I don't get to see the source code. Okay. So it is something that is probably inherits from tuple, does all the things tuples do, but is not itself exactly a tuple. Is instance tr hang on. C dot size tuple. Can I do that? It's true. And yet if I say type of z dot size, torch dot size. So here's the thing. If you did this, if you're checking your types like this, you can get burned. If you tap your types like this, you're generally much safer because this is a form of tuple. It's just a subclass of tuple in some sense. But if you're literally checking exactly, then it's not going to be a good time. Okay, that's cool. That's cool. That's how you get the size, and you call it as an object on there. So if I say s equals tr dot size, I don't like that it's capitalized. Or no, that's the type. That's right. Z dot size, like this. And this is like a tuple. Yeah. Can I just add things to this? I can only add a tuple, not tensor to tuple. Yeah, that's what I thought. Like, how do I turn it into a tensor though? Can I do tr dot tensor? I think tensor. Okay, cool. And then I wonder, like, will it leave the GPU when I do this? What if I want all these? What if I need to grab the size of something while without leaving the GPU? Because that's slow for whatever reason. Because I might be working on something where the size is dynamic. So that could be trouble. Yeah, you can add your things. That's all typical. Or you can call add, but nobody's going to do that. This is way easier. You can store it in a result if you really want, but that's insane. Don't do this. Do result equals x plus y. That's the only sane thing to do. Good God, don't do this. Do, oh my gosh, something insane. Z and x, right? Watch. Z plus equals x. Boom. In place, addition. Alright, this number was super small. That's why you didn't see it. Let me make new things. I have x and y? No. I have y and y2. Right. Y plus equals y2. Boom. Look at that. Yeah, do this. This is Pythonic. This works. If you want to be really super explicit, you know, y equals y plus y2. That's fine too. Don't do... Geez, oh man. Like, why would you do this to yourself? Why? This... Humans don't read... Like, no one does math this way. This is a very Ugh, it's a mess. This is great. This is wonderful. This is also fine if you want to be explicit. Don't do this. I don't even know why they show you can do that. That's dumb. Okay, it's just like needlessly object-oriented. NumPy like indexing works. Cool. That's super cool. So if I say z of, I don't know, I want 1 to 3, comma, I want, no, hang on. I want actually 1 to 4, skip every 2, and I just want, 1 to the end here. Shazam! Look at that. Nice. Of course. They're all 1, so it doesn't really look that interesting, but that's okay. That's super cool. View. What is view? If you want to resize, reshape, use torch.view. What? Reshape tensor. Change the view. There's not like a reshape command? Nah, there is. I bet it's... How is it different from view? Here's the new tensor with the same data, but of a different shape. So why would I do one or the other? Interesting. Size -1 is inferred from other dimensions. Yeah, it's pretty typical. So you got this thing. I got y. I can say y to reshape. Probably -1, comma 4. So the first dimension is going to be negative. It's going to be however long it needs to be to make the other dimension equal to 4. So it's going to be 1, 4 is what we're going to end up with. Shazam. Y we didn't change. We just reshaped it. Oh, I bet whatever does .view change it? -1, comma 4. Does that change things? No. They do the same thing. I don't know why you'd use one or the other. Like reshape is how it's done in NumPy, and that's my gold standard. Do whatever NumPy does. Do reshape. Like, it's a nice, good, sane thing to do. Do that. This method returns a view if attribute shape is compatible to current shape. See whatever view on when it is possible to return a view. So a view is something slightly different from a reshape. Returns a tensor with the same data and number of elements. So this might, it's possible you'll end up getting a copy of your data, whereas view will never do that, I gather. New tensor, same shape, well, they're different. Shares the same data and must have the same number of elements, but maybe a different size. Maybe a different size. Okay, hang on. So, I got this y thing. y2 equals y dot reshape of, -1, 4. Right, different shape. y3 equals y dot. It might be something about sharing memory versus not. Right? Y, y2, y4, y3. If I say y3, the view of the first one equals 0. Let's change to y3. Whoa, what? Oh, son of a gun. Hang on. Well, I reset everything. Yes, because the first, it's a 1/4. That was dumb. Alright, hang on. Let's remake some new numbers. Do this. Do that. y3 of 0, 0. Aha. Set that to that. Now we just zeroed out the first thing, right? Let me look at the original y now. That 0 is out there. y2 also 0 is out there. Say y2 of 0, 1 equals 1. Changes the original. Changes this one. I don't know. They look very similar. But there must be some esoteric blah blah blah. Each view dimension must be a subspace. Example. Not change tensor layout in memory. Interesting. Well, yeah. I mean, that's pretty typical. Does reshape change the layout? I didn't think so. Interesting. Oh well. I'm not going to worry about that too much. You can get the size. It's different. It's how you reshape. I'm going to stick with reshape until I get burned, which maybe will happen. Yes, you can call all this and other stuff. That's great. NumPy bridge. Yes, I already discovered that. That's good. Let's do... Oh boy. Running PyTorch with examples. Let's just do something different. Warming up. No, I don't need to warm up. Oh god, why would you... don't compute gradients yourself. There's already ways to do this. Good gravy. What are you doing? Why would you do this to yourself? Oh, it's like there's no like Keras like thing. Autograd. A fancy way of saying we're going to compute the gradients. What a hot mess. Like again, you're forcing yourself to compute all this nonsense. Like Keras is just so good. And even like without that. Okay, here we go. Now you're making a model. Now you're getting somewhere. You're still having to do this nonsense. Jeez, oh man, like you don't want to be thinking about that math when you're first making your model. Oh my goodness. Random tensors, all inputs and outputs. Okay, you know what? Well, I'll grab some of this stuff. We'll try this. I want to see how if it actually trains. I'll say this is working way better than it was before. Way, 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 way better. Well, apparently I was trying to do some stuff here. Here's a question. Does this stuff still exist? Oh, it does. Oh my gosh, my stuff from like 4 years ago. I'll give them credit, like that's relatively stable. Requires grad equals true. Okay, cool, cool, cool. Need to define X, non-flat features, all dimensions. What was I doing here? I got this done in an hour? I don't even... Oh, it's some silly, crazy convolutional model, which I don't really want to do. We're not going to get to that point today, I don't think. Okay. Yeah, make some dopey, empty data there, right? I love that you can just look at those. That is so dang convenient. Is it the same number when I look at it again? Oh, it is. I love that. In TensorFlow, it might change, but not in Torch. That's super cool. You make a little NN package to define our model. Okay, so NN, torch.nn, I'm gathering is Similar to Keras. Alright, we clean up a little bit of this here. So we're going to make ourselves a little model of... Jesus Christ. I hate this non-Pythonic nonsense they're doing here. It's horrendous. It's a crime. A crime, I say. Just pass in a list. Don't pass in a bunch of arguments unless you have a good reason to do that. It's fine to support that. I hate it. Okay. Yeah, let's do that. List is not a module subclass. Seriously, you can't do this? You gotta be kidding me. That is criminal. Args. Order dict is an option. Interesting. Or I just pass in not the list. That's the dumbest thing I've seen. Torch NN sequential does not support a list. Oh my god. Torch NN dot sequential like list input. Insert a given module before a given index. Why should I use? Consider to be a module parameter. No. Base class for all neural network modules. No, that's nothing. These are very esoteric solutions. Doesn't accept list input. That's just insane. Yeah, why can't it handle multiple inputs? Or why can't it handle... Yeah. Accepted an order dict, and a module list accepts a list. Okay, module list is what I want then. Again, people probably maybe screaming in the chat, that's fine. Module list. Index like a regular Python list. Iterable, optional. And iterable of modules to add. Yes. Why doesn't your regular module one support this? Yeah. We went to loopback initialize module, list.append. You can unpack. Yeah, I understand you can unpack. That's dumb. And this is like last month people were arguing about this. In the end, the changes were rejected. You could, of course, use post a custom sequential derivative, and if it makes the definition easier. That you're insane. In this PR and this one, I wanna know why. Why are you not allowing this? Yeah, okay. This guy's like, boom. Here's a pull request. Fix it. Please use this for questions. You sure this is not a bug? It's not a bug. Why? Like, what is the line of reasoning here? More reasonable and solve my question. Yeah. And again, like, people have solved this problem, but you just don't like it. Blah, 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 blah. If anything takes more than one input, it depends on a lot on the application, so I'd rather not have it. Again, this is just super weird. Just like the inputs are unpacked, all intermediate outputs are implicitly unpacked. It's just such a strange way to do it. Like, this is supported in Python, so you can support variable numbers of arguments. I don't think this is a good use case for variable numbers of arguments. Like, it's a good use case for a list. Complicates the types we expect. More downvote than upvote. Feel free to close this. What was the votes? There was more upvotes. There was more upvotes. Curse you. Foolish PyTorch. You're a real mixed bag. I gotta tell you. Okay, so I can't do a list. What a crime. What a crime. Nonsense. All right, let me. Ugh. Make my model, turn off my auto indent. I'm a terrible person. That just feels dirty. I'm being more irrational about it than I really should be, but. Okay, what are the things you can do here? Is there like a model.fit, say? Forward. Half modules, name buffers, name children. Oh my goodness. Requires grad, share memory, state tick, train. Hey, you know. Wait, what? Sets the model in training mode. No. Only has an effect on certain modules. Okay, that's not what I want. Good idea. Oh, no, okay, that's it. Apply? Is that a thing I want? Applies the function recursively to every sub. Jeez, oh man. Okay, that's not what I want. What do? You create... Oh, I see. You make the model. This is your model. Then it's like you instantiate it? No, you're calling on X, whatever X is. Let me get the loss function first. Oh boy. Like, Keras interface, so good. So good. Right, mean squared error loss on whatever the direction is. The sum, the mean, doesn't matter. So we're going to be fitting a bunch of parameters in here. Some linear layer, some rectified linear unit, and then some linear output. Do some stuff, get some answers. No, not that. But you're saying ypred is equal to, of course, model of x. That's just sort of a definitional thing. This is whatever their predictions are that the model currently spits out. Those are the numbers it was supposed to spit out. It did a not good job. And it's not going to do a good job because we're just using random numbers. But you, like, set up the learning rate in this manual frigging way. Why would you do this to yourself? I get lost on backwards. We've updated ways by manually mutating custom init. Is this as good as it gets, PyTorch? Like, I run TensorFlow to do these things, but like Keras makes it so convenient. But like, I have to say, I want to compute the loss now. I want to compute the loss. And I want to zero out the gradient. Oh, what's my optimizer? Hang on. Okay, get your optimizer. It's feeling familiar. This is our optimizer, right? Learning rate equals, I don't know, 1e -4, that's fine. And you zero it out the optimizer's gradients. Use the optimizer, oh, because it knows about the parameters. Okay, that makes sense. And then you call it backwards. Then you backpropagate, you know, compute them derivatives. Yep. And then you update all your values. That's a little bit easier. It's still kind of a pain. Is there a Keras interface to this? Is there tr.keras? No. Capital K Keras? No. Tell you what, let's run this though. We have all this nonsense. We're in range. I don't know, 10. Whatever. They have some stuff, right? Loss.item. Yeah. Print loss.item. I have to compute the loss every time, right? Yeah, okay. Loss.item, which grabs just a single thing when it's a long tensor. Okay. Make this. See how this goes. 10 steps, 10 epochs. Loss is decreasing. What do you know? Amazing. But like, there's not a built-in way to handle validation data, say. That's a little annoying to me. PyTorch Keras equivalent? Yes. PyTorch equivalent of Keras. PyTorch forms. Moving from Keras to PyTorch. Keras versus PyTorch. I get the feeling that like PyTorch obviously gives you more power than a straight Keras. Jesus, what the? Oh, they recommend you define a class structure, of course. Of course they would, because they love object-oriented. Like, but this is so dang convenient. Like, I see what this is. I add, bang, 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 bang. Here you're seeing I'm doing different things. I'm defining a bunch of stuff. This is separated from this. You see how inconvenient that is from a logical perspective? Corresponding number of channels. Yeah, this isn't really. This is not the equivalent I was looking for. These three, yeah, I understand, like, you can build your model in this wacky way. PyTorch to Keras. On the other direction. Yeah, like you see how you just like, oh, I'm making these different types of things and then I attach them to each other. That's just super annoying to me. I would much rather just build it directly. Yeah. None of them looks correct. Great. So, I'm sure PyTorch does some great things. Doesn't make it easy for a beginner. Yeah, I bet. Let's make a new window, incognito. Because I don't really need your cookies towards data science. You have some good posts, but you have way too much crap on your pages. I will say PyTorch worked with CUDA, having already set it up with TensorFlow, of course, but I didn't have to futz around with that. It was easy to install. Give that a lot of credit. It's got some nice features. I really love the eager execution that I can just see things. But my skin is clear, my eyesight is improved. Yeah, but it's all object-oriented. It's written by computer scientists. But I'm more of a data scientist. I'm more of a mathematician, really. That's what I kind of want. There's a PyTorch class. Yeah, classy. Cute. Cute. Yeah. Easier to debug. I'm not so sure about that, my friend. Oh, well, yeah, that might actually be true, because you can have more access to your data. Turn multiple outputs from a forward layer. That's true in Keras, too. PyTorch layers work very similar to NumPy arrays. Yes, that is convenient. Different layers with different initialization schemes. Something you won't be able to do in Keras. I'm pretty sure that's not true. You can definitely set up different initialization schemes in Keras. Maybe this was written, this is old, I don't know. Maybe it's a sort of control. But look at how much longer it is. You gotta define the whole forward step yourself. Torch can't really drop out. Like with TensorFlow, I can do all this stuff to get explicit control, and then just call Keras.fit, because I made it a model that Keras can understand. It's super good that way. It's not so good about other things, but it's getting better. Highly customizable training loop. I wrote that you will be amazed once you saw the training loop. That was an exaggeration. You will be baffled and confused. Yes, that is true. Torch to tensor, all this other nonsense. Compute loss, clip the gradients, calculate loss, print. So again, it's like I have to define all this stuff myself. When, 90% of the time, I'm just doing something, I just want to be able to hit train. That's what I want to do. Why? Why so much code? It's probably a handful. Alright. Like, you even understand. Get a lot of power. Get that same power in TensorFlow! Yes, I understand you're going to get along, but I'm going to spend more time writing that code rather than thinking new machine learning solutions. I am not as impressed with this. Okay, so that just seems to be the way, like, this is the fundamental construct of PyTorch. Like, you have to roll your own training loop. Like this. Which is not terrible, This is like, oh, whatever, it's 5 extra lines. It's not that big a deal. But, with Keras, you get some really convenient things. You get, is it sequential? You can just call fit. This is the point being, like, you can quickly set all these things. You can set a bunch of different parameters, even if you build your model in TensorFlow. So, actually, I want to know, is there a PyTorch interface to Keras? Or a Keras, other way around. Keras interface to PyTorch. I don't want to move from one to the other. I want a Keras interface. Keras-like framework or PyTorch. Like, because Keras is really just a API specification. You can make it work in whatever backend you want. Poutine, of course. Cheese and fries. It's got Canadian, possibly. That's cool. That's super cool. Compatible latest version of PyTorch. There's a model. Makes some random data. Makes a PyTorch network. Oh, just literally num features, num classes. And then he creates a model from the PyTorch network. Okay. It's got your specification, all this stuff, and he calls that fit. Yes, that is what you need. Putine. Setting limits on the predictions. I don't know what this other person's doing. This looks pretty good. It's recent, last updated last month. Alright, Putine might be what we're looking for. In fact, let's sudo pip install. Let's do Putine. Dang it. Putine. Let's see if I can do that. I have 10 minutes. 10 minutes left to try Putini. Let's try PyTorch with... what is your preferred pronunciation? Okay. Getting started. Do you have an FAQ? Why this name? Okay, Poutine Québécois. Well-known dish. French fries, cheese curds, gravy. Also something meaning of ordinary or common. I didn't know that. Poutine. Ordinary boilerplate code the plain PyTorch string usually entails. Oh, okay. Well, that's super cool. I dig it. You have some stupid simple example, don't you? Yes, you do. You're awesome. Right in your main page. This is what we needed. This is what America needed. Oh, look, training, validation, test, right here. Bam, 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 bam. This is good. I'm a fan. I am a fan. Okay. That's super good. We're installing Poutini. I would better just, from import Poutine. Oh, here we go. Here's what I'm going to do. I'm going to import Poutine as PT. The new LIC model. Oh, I don't have that yet, right? I need to make my model, right? Make a dope network. Actually, yeah, it's fine. Make a dope network. I don't really care about that. We'll copy some of this code just to get what we got going. Again, TR, so don't go crazy. Oh, so cool. Now with Poutine. I'm already digging Poutine. I like the name. I like what it is. If it lets me use PyTorch, if it mitigates what are, to me, the annoying parts of PyTorch, God dang. Let's mark this up. Set paste. That's what I wanted. Doink. Model now is going to equal Poutine.framework. It's not model. Right? Yeah. Okay. Cool. We have Poutine. Awesome. I was about to say I love America. J'aime Québec. Ce qui me plaît, c'est Québec. Alright, Poutine, let's go. Oh, awesome. Oh no, I never imported NumPy. That was terrible. That was foolish of me. Foolish. Okay, there we go. Got some stuff. We have a few minutes left. This is gonna work. It has to work. Yes. So look at that. What is the thing we're optimizing? The network that has some set of inputs and outputs, right? PyTorch network. What kind of object is this? It's all linear. In features, out features. What does this even do? Oh, this is some set of inputs, outputs. Right. Okay. So you could have some wacky thing like this thing, this model object up there. Right. That is a network of some kind. You can do the same thing. We might try to do that. Maybe not this time, maybe next time. Alright, let me do this. There's no HTTP framework. Really? Ah! It's one of those. That's annoying. What does it have? Nothing? It's got things. That's annoying. What if I did this? Yeah, okay. That's irritating. Really irritating there, my friend. Really irritating that I have to import it that way. But I understand. That's how it's got to be sometimes. Oh, now I got this model object. What can I do with this model? Can I do summary? Not yet. Oh, but I can set weights? Can I get weights? Oh, glorious. Oh, and these are the actual, is an order dict. Really? Well, that's cool. The weight of this tensor and then a bias term. What is the difference? The dictionary containing the parameters of the network. Tensors are just references to parameters. Oh, so I can change them right here? Hang on. Back the fun bus up. Back the fun bus up. I have direct control over the weights. So if, I don't know, for example, I looked at, oh man, I can just change them all right here. This is a wicked power right here. Maybe this? Yeah. Nope. Now it's 0. Boom. Okay. And we get the weights again. This number should be 0. Oh, that's cool. You can just, oh, that's wicked cool. I'm a fan of that. I'm gonna keep that over here. Get weights. Not a copy. W of bias. Here we go. 0 equals 0. Effects model. Oh, that's super cool. I am a fan. I'm a super fan. You got your validation, you got your graphics, you got your batch size, you got all this other stuff. Cool. Model to fit. Which means network kind of data set, usual kind of thing you expect. Is there a validation split option yet? Validation steps? No, not yet. Okay, well that's cool. I understand that. I appreciate. You don't have all that stuff yet. Zing. Oh, and that's the history object, right? Dunk. That took that was way too quick though. I don't know, 100, whatever. Okay, I want to see. Okay, it's not quite a progress bar like I'd want. Oh, maybe it's way too fast. It's a problem because it's just a linear model. Yeah. Okay. What if I had way more data? By way more data, I had like 80,000 of these points. I don't think that'll destroy my computer, so I think that's okay. There. That should take a little bit more time. Okay. So I don't get a progress bar, but I do get to see the step size, or the step number I'm on, so that's actually fine. Alright, so Poutine to the rescue. Able to save PyTorch from when I'm doing annoying boilerplate code that I shouldn't have to write, because if I write it, I end up writing it a little bit differently every time, and I'm going to get it wrong. Well, alright, so I'm going to have some little reference document that I always refer to. Guess what? That reference document, now it's called Poutine. And that's just what I'm going to use. That's super cool. Okay, I think next week, then we will take a closer look at Poutine. We'll try to PyTorch out on some more advanced things. This is cool. I was glad to be able to find something to fix that. So, final thoughts on PyTorch. I really love the eager execution. I think it's come a long way. It works much more seamlessly with CUDA. There's a couple weird features where they don't let you pass in a list. That really grinds my gears. And that the preference being that you pass in objects like this is annoying to me. I think that's non-Pythonic and that's bad. Whatever, they wrote it, not me, so they get to choose. But it's pretty good at what it does. This is kind of annoying. I appreciate this gives you fine-tuned control, and I should have that control, but there ought to be a simpler interface for most people to use. Thankfully, Poutine to the rescue. If you never had poutine, it's quite tasty. Potato, cheese curds, or fries or chips, depending on who you are. Cheese curds, gravy, that kind of thing. I've also heard it described by various Canadians as an excuse to put whatever you want on fries or, again, chips, depending on where you live. That's super cool. Alright, so I'll definitely be checking out poutine more in the future. I just love the name, too. That's just hilarious. That's like, I mean, Karis was a name, you can pronounce it, but poutine, that's fun. It's spelled with a Y, that's hilarious. A+ on the name. Plus, it seems like a good library. I love that. We'll definitely do a model, do a whole video on that next week. Alright, that's all I got for this week. Thank you very much for watching. Stay safe out there, and as always, stay safe in the data mines.